Hi, the purpose of this video is to learn how to solve equations with like terms. So let's get started. Well, let's first identify the types of problems that we're going to be looking at. As you can see here, I've circled 5 different problems. By the end of this video, you should be able to solve all of those equations. So, I'm focusing on a very specific type of equation. It's equations with like terms. So we have to know what like terms are, and the best way to to really understand what it is, it's helpful to see an example. So for my first example, I'm going to have 3a plus 2a. So this is an example of like terms, and the reason for that is because the 3 represents how many a's I have. So the number 3 represents it's a coefficient, and a is your variable. So I can rewrite this term as a plus a plus a. That number 3 represents how many a's I have. So that's why I added 3 a's. And if I were to look at my second term, I have 2a. So my coefficient is 2 for this term, and my variable is a. So if I were to expand this, I would also write a plus a. I only have 2 a's this time. So the benefit to having like terms is when you have the same variable with the same exponents, you can add them and subtract them. So in this case, I have 3 a's in my first term, and I have 2 a's in my second term. So when I add that together, I have 5 a's total. So that's an example with like terms. Here's a counter example. So here's an example that does not have like terms. So if I were to add, let's say for example, I have 3a plus 2b. I have 2 different terms. The 3 represent how many a's I have, and I have 3, so I'm going to write a plus a plus a. In my second term, I have 2 b's, so I'm adding b plus b. So these are not considered like terms because the variables are different. For one term, I have a's. For my second term, I have b's. There's no way to simplify this and add them to be one term. So unfortunately, my final answer when I simplify this expression is 3a plus 2b. I cannot simplify that any more than it already is. So that's what happens if you do not have like terms. You can't add and you can't subtract them to make one term. So why is that important? Well, in my 5 equations, we have like terms, so it's important that you collect your like terms first before you solve. For my first equation, I am asked to solve for x. So I have 2x plus 3x is equal to 15. So, as you can see, I have x's in 2 different terms. So right away that tells me I have like terms and I need to add them together so that I can simplify my equation more. So all I have to do is add the coefficients to determine how many x's I have total. So 2 plus 3 is 5. So I have 5 x's total. So 5 times x is equal to 15. So now that I have simplified, now I can solve my equation. It's very easy. I have to use the inverse operation. Whenever you see a number next to x like this, that means that it's being multiplied. So 5 times x is equal to 15. So to undo multiplication, I have to use division. So I'm going to divide both sides of my equation. You'll notice that I have divided, my equal sign is right here. I divided 5 on the left side of my equal sign, and I also divided on the right side of my equal sign. In order to maintain equality, you have to use the same operation and the same numbers on both the left and the right hand side of the equal sign. So 5 divided by 5 is equal to 1. So my it did just what I wanted. I got rid of the 5. So now what's left is 1x is equal to 15 divided by 5, which can be simplified to 3. So my final answer is x equals 3. Now, if I wasn't feeling confident, I wasn't sure if my answer was correct, I can always do something called a check. This is a very popular thing to do when you are solving for equations, especially when they're complex. Equations, it's so nice with a unit like this, solving one-step equations, two-step equations, multi-step equations. Any type of equation can be checked, and it allows you to determine if your answer is correct. So that's the reason why we do checks. So I'm checking to see, is my answer correct? Is x actually equal to 3? In order to determine that, I need to write the original equation, 2x plus 3x is equal to 15. So all I have to do is substitute x. I know that x, according to my calculations, is equal to 3. So anywhere I see an x, I'm going to write the number 3. Now I want to go back and remind you that 2x means that I'm multiplying 2 times x. So it would not be correct to say 23. That's a product. 2 is being multiplied by x. So I need to have parentheses there to represent that product. So 2 times 3 plus 3 times 3 is equal to 15. So now I can simplify this. 2 times 3 is equal to 6 plus 3 times 3 is equal to 9 is equal to 15. So now I will finish this up. Last step, 6 plus 9 is equal to 15. So I did end up getting the same number on the left and right hand side of my check. So that tells me that I got the correct answer. In the event that I didn't get the same number, let's say, I'm going to write the wrong number by the way, I'm just warning you. Let's say that I had, I go through all the math and I get 10 equals 15. Okay, well, one of two things. Either I did not correctly solve for x and my answer is wrong for x, or I could have made a mistake in my check. So that's something that you need to go back through. If your check doesn't get the same number on the left and right hand side of your equal sign, you need to fix that. So it's nice. You kind of get to play teacher in a way when you do your checks, because you can grade yourself and tell yourself whether it's correct or not, and to go back and fix it if it's necessary. So this is the correct answer. 15 is equal to 15. Everything checks out. I can move on to my next problem. So question 2. We're solving for y this time. It says 8y minus 15y is equal to 21. So I need to subtract. I know that I have to simplify my terms before I can solve. So 8y take away 15y is equal to negative 7y. So negative 7y is equal to 21. So I know that I have to use the inverse operation to solve for y. So I'm going to divide. So divide both sides by negative 7. Negative 7 divided by negative 7 is equal to 1. So those cancel out and I'm left with 1y on the left-hand side of my equal sign. So 1y is equal to 21 divided by negative 7 is equal to negative 3. So my final answer for this problem is y equals negative 3. Now I could do the check with you, but to save time, I'm going to let you do that on your own, and I'm going to move on to question 3. But I want to emphasize the importance of going back, checking your work, and making sure that you agree with the answer that you calculated. So I do encourage you to do the checks on your own for all of these equations that I have here in the video. Alright, moving on to question 3. We're asked to solve for z. So this time you'll notice I only have one z here. Z minus 4 plus 3 is equal to negative 6. This is a unique question because this time my common or my like terms are actually something called constants, which are numbers. So my constants I've highlighted in blue. Constants are numbers that are either added or subtracted to a variable. In this case, negative 4 and 3 are constants. So I can add these two numbers together to simplify my expression a little bit. So z minus 4 plus 3, well, that's the same as z plus negative 4 plus 3. Something that we talked about in class. Subtracting is the same as adding the opposite number. So instead of subtracting 4, I added negative 4. Reason being, I wanted it to be abundantly clear that these were the two numbers that we were adding together. Negative 4 plus 3. I didn't want you to overlook that that number 4 is actually negative. So z plus negative 4 plus 3, let's combine my like terms. So I have z plus negative 1. Negative 4 plus 3 is equal to negative 1. So z plus negative 1 is equal to negative 6. I can simplify this farther. Z plus negative 1 is equal to z minus 1. So I used the same rule. I know that subtracting is the same as adding the opposite. So instead of adding negative 1, I subtracted the opposite. So z minus 1 is equal to negative 6. I just want to make a little note that these steps that I have here, I starred them in black. Technically, they're not mandatory. I wrote them out so that you understood how I went from what I was given to this step right here, which is z minus 1 equals negative 6. Technically, you could go from this step to this step if you understand the math. Okay, now that I've simplified, I've collected my like terms, I can go ahead and solve for z. So once again, I have z minus 1 is equal to negative 6. So in order to solve for z, we need to use the inverse operation. So instead of, so to get rid of subtraction, I need to use addition. That's the inverse operation. So I'm adding 1 to both sides of the equal sign. So the 1's cancel out, and I'm left with z is equal to negative 5. Negative 6 plus 1 is equal to negative 5. Okay, question 4. We have m plus 11 plus 2m is equal to 11, and the question is asking us to get m by itself. So we're trying to figure out, all right, what number is m going to be equal to? Well, this does have like terms. M is in two of my different terms, and you'll notice the variables are not next to each other. So that's another thing that's unique about this problem. So addition, luckily for us, is commutative, which means that I can change the order of my terms and it won't affect the answer in any way. So I'm going to rearrange this so that my variables, my like terms, are next to each other. So I'm adding 1m plus 2m's plus 11, and that's equal to 11. So I know that if I have 1m plus 2m's, that means that total I have 3m's. So 3m plus 11 is equal to 11. So now that I've simplified, I've collected my like terms, now I can solve this two-step equation using inverse operations. So I'm going to start by subtracting 11 on both sides of the equal sign, and I'm left with 3m is equal to 0. So once again, I have to use the inverse operation. 3 times m is equal to 0, so the inverse operation here is division. So I'm going to divide both sides by 3, and those numbers cancel out. So I'm left with just 1m. So 1m is equal to 0 divided by 3 is equal to 0. So my final answer is m equals 0. Last question, guys. Number 5, and this is the most complicated of them all. So I have a combination of two different like terms, two pairs of like terms. So first, I want to point out that I do have constants. I have two constants that I'm going to have to add together. So I have negative 8 plus 10. So that needs to be added together. I also have 3t and that is being added to negative 5t. So I need to collect my like terms, but before I do, I need to point out a concern of mine. Subtraction is not commutative. So that means that order cannot be changed when you are subtracting. That means that order matters when you're subtracting, and if you change the order of a subtraction problem, your answer will be incorrect. So order matters, and because of that, I can't just move around my terms without thinking about it. So to avoid that problem, because I have subtraction there, I'm going to rewrite that as a sum so that order so that the order of my terms can be moved around without affecting my answer. So instead of writing minus 5t, I'm going to write plus negative 5t. Now, for those of you that have been really experienced in solving multi-step equations and collecting like terms, that may not be a necessary step, but I want to include it in that step just so that we are clear that we are not moving our terms without considering the fact that 5t is actually supposed to be a negative term. That's why we had to subtract here. I'm going to highlight that in red so it stands out. That subtraction sign means that I had added a negative term. So 5t needs to be negative in your work. I can change the order of my terms now. 3t plus negative 5t plus negative 8 plus 10 is equal to negative 18. So having my like terms next to each other is nice because then I can very quickly do the math, and it's just nice and organized. So 3t, take away 5t's, so I'm basically adding 3 plus negative 5, which is negative 2. So I have negative 2t's plus negative 8 plus 10 is equal to positive 2. So my final equation, when it's been simplified, is negative 2 times t plus 2 is equal to negative 18. I have collected my like terms now, so I can solve my equation using my inverse operations. So let's start by subtracting 2 on both sides of the equal sign. So I have negative 2 is equal to negative 20. And another way of wording that is negative 2 times t is equal to negative 20. So the inverse operation of multiplication is division. So I will divide both sides by negative 2. So my final answer is t equals positive 10. So that wraps up my video. I hope that this helps, but I will admit that practice, practice, practice. If this seems like it's really difficult, it will only get easier with patience, time, and practice. So don't give up and keep up the hard work. Thanks for watching.